Now let us get into the next problem. Here we are going to draw the isometric projection of a truncated solid. So as you know, truncation means when you have a solid cut by a cutting plane which is inclined and top portion removed. The left out is called truncated solid. Now we are going to draw the isometric projection of a truncated solid which is a pentagon from it. The same problem, we will see what are all the additions we go and get here. So I quickly get into the drawing of simple front and top view here. Okay, so draw the XY line, draw the top view, name the corners, name the apex point, draw projectors, draw the axis line, get the slant edges, name the base corners and the apex point. Fine. Up to this we had of course just before seen. Now as usual enclose the base pentagon in a rectangle. I think which is very light. I think you can able to see here. Base pentagon in a rectangle. Now comes the addition. Oh, we of course before that name the corners of this rectangle. Addition is there is a cutting plane which is inclined and passing through the solid. Say the position of this cutting plane is given in the question at a specific height from the base. Say now the cutting plane will generate cut points, isn't it? So of course we have to name the cut points to become 1, 2, 3, 4, 5 are the cut points that we have to name. Because I have 5 cut points, I have named the corners of this rectangle as 6, 7, 8, 9. Now I have to draw the isometric view of this truncated solid. Truncated solid again means I am going to draw the isometric view of this portion. We will see how I am going to do that. So first draw the reference line, draw the isometric view of this rectangle. I think which you can able to see, and transfer the what we call the corner points 6, 7, 8. And very importantly here I have chosen 7 as the resting corner. You always choose that particular resting corner which is closer to a cut point which is at minimum height from the base than other cut points. For example, I have 5 cut points here, right? 1, 2, 3, 4, 5. Now this is the cut point which is at minimum height from the base. The corner closer to that particular cut point have to be the resting corner, just for one simple reason that then only I can able to see the section in the isometric view. Okay, so just to make sure that you are completely seeing the sectional surface, you are picking that particular corner which is closer to the point which is at minimum height from the base. So 7 is that particular resting corner. So I have completed the isometric projection of the rectangle which I used to enclose the pentagon, and then as I just did before, transfer the corner points to this and got the naming of these corner points as well, got the image of the apex. I think you can able to see it got the image of the apex. So once I get the image, I can transfer the height, emit, or those cut points are named just now. So as you can see here, cut points are named as 1, 2, 3, 4, 5. Should have been just before. Anyway, once you got O, connect O to the base corner points A, B, C, D, E. Okay. Kindly notice that I have done this with a lighter line. Why? Because my objective is to get the truncated solid. So got OA, OB, OC, OD, OE connected using lighter line. Right? And then I have to trace the cut points. Now how? See, just look for these orange markings. So how I have done that? Say first, similar to how I transferred A, B, C, D, E, the same way I have to transfer the cut points from 2, 3, 4, 5. Now how to do that? You have to first, of course, transfer, let's say one is on the line OA. Okay, one is on line OA. Just drop perpendiculars like this. Okay, now we will end up with this particular pentagon. This will give the cut points. Remember, to trace the cut point in the isometric view, you need x, y as well as z informations. Right? This is called offset method. Okay, the method which we are adopting right now is called offset method. Okay. Now let us say, for example, uh, I am going to trace cut point 1. I will remove the other projectors. I will I will just drop a projector from 1, okay, to the top view, which is over here. Okay. Now this is the projection of 1 dash on top view, which is 1. 1 I have to trace, isn't it? So to trace 1, you have to get two information. As I just before mentioned, let us assume this as x direction and this one as y direction and this one as z direction. So now the point 1 is this much distance in the x direction from 6. Similarly, this much distance from 6 in the this much distance from 6 in the y direction. So transfer these two informations here first. So from 6 all along the 6, 7, 9, you transfer x information. And from there, draw a line parallel to 6, 9. Okay, that is very important. Parallel to 6, 9 in the y direction. That is here. This is x direction. And this one is y direction. So I think you got the point. So once I get this particular point, I have to get the height of point 1, that is this distance from the front view, and from here for that particular height, drop a line upwards, you automatically get this particular cut point. Okay, 3 things I have done. Now what I have done is I transfer the point 1 into the isometric view by tracing the point 1 in the simple front and top view. I got x in y information from the top view, and then I got z information from the front view. Same way I have traced the other points A, B, C, D, E. Sorry, 1, 2, 3, 4, 5. Not named here anyway. These points are, so this is point 1, this is point 2, point 3, point 4, and point 5. So the cut points are traced by getting informations from the front and top view. So how you trace the cut points? You get x and y informations from the top view and z information from the front view. Transfer one by one to trace the points, especially in the cutting plane. Okay, I hope you have followed me. So I very briefly repeat. I just first transfer the X information, then I transfer the Y information by dropping a parallel line 269. Then from there I transfer the Z information to place this cut point X, Y and Z. Same way the other points, and then join the cut points in the specific order. Once you have done that, join these cut points to the corresponding base corners as we done here. One is connected with A, and then 2 is connected with B, 3 is connected with C, 4 is connected with D, and again 5 is connected with E. So, how I graphically do this? Let me go and see. So E2 is connected to B, 3 is connected to C, 4 is connected to D. Of course, 5 is anyway that particular standard is hidden, so I have not shown here. Now I got the isometric view or projection of a truncated pentagonal from it. You can see only that particular portion which is left out after having this cutting plane passing through the solid drawn with HB pencil. Okay, so this is called isometric view or projection of a truncated solid. You should only show the visible edges, name it with capital letters. Okay.